Hello students, welcome back to this new session on mathematics for the subject 18mat31. I am your mathematics teacher from AITM Bhatkal. Here I have written some standard Laplace transform which I will be using in the problems. Okay, I request all of you to copy down the same. Okay, it is shown in your screen right from the first Laplace transform, that is Laplace transform of e to power at 1 divided by s minus a. Laplace transform e to power minus 8, it becomes 1 divided by s plus a. Similarly, the Laplace transform of cos hyperbolic at, s divided by s square plus a, s square minus a square. Sin hyperbolic at, a divided by s square minus a square. Cos at, s divided by s square plus a square. Sin at, a divided by s square plus a square. These two things I had asked you to work for homework as an assignment. I don't know how many of you have worked for that. Better you work for it, you will get these two. Okay. Similarly, the Laplace transform of t raised to n, which we have just now in my previous session we had derived it to be gamma of n plus 1 divided by s raised to n plus 1 or n factorial divided by s plus 1. Okay, s to the power n plus 1. Okay, now just one thing you have to notice with hyperbolic only, with hyperbolic Laplace transform for the hyperbolic functions, they are same as the Laplace transform of normal trigonometric functions. Only difference is that you get a negative sign here in denominator, s square minus a square, here also s square minus a square. With normal trigonometric functions, with cos you have again s for both, whether it is hyperbolic or normal trigonometric functions, you have s in the numerator, and denominator it is for normal trigonometric function it is s square plus a square, whereas for hyperbolic you have s square minus a square. Similarly, in the sign also you have got a, the constant, divided by s square minus a square for hyperbolic, and for normal trigonometric function you have s square plus a square. Means what, the denominator for both trigonometric, normal trigonometric or the hyperbolic, they are the same. See, look at this, cos hyperbolic denominator, sin hyperbolic denominator is same. Only here s appears with cos, with sin it here a appears. This trick you can use to remember these basic Laplace transforms. Okay. Now let us start with the problems. We'll work few problems on these formulas. Okay. Yes, here we have got one problem. Find the Laplace transform of e to power minus 2t sine hyperbolic 4t. Okay. To start with the solution, first let us simplify this. What is sine hyperbolic 4t? Okay. Now what is sine hyperbolic 4t? By the definition of sine hyperbolic functions, we know that it is equal to e to power 4t minus e to the power minus 4t over 2. Is it not? Now let us substitute in this e to power minus 2t into sine hyperbolic 4t, becomes what? It is equal to e to power minus 2t into e to power 4t minus e to power minus 4t divided by 2. That is, I am just substituting sine hyperbolic 4t. Okay. Now let us multiply this bracket, this e to power minus 2t inside this bracket. So you will end up with what? Let us write half aside. You will have e to the power minus 2t into e to the power minus 4t. It becomes e to the power 2t by applying laws of indices. Minus e to the power minus 2t into e to the power minus 4t. Multiply it, you will get e to the power minus 60c. Okay. Now we have to apply the Laplace transform e to the power minus 2t into sine hyperbolic 4t, becomes what? It is equal to half aside because it is constant, the Laplace transform of e to the power 2t minus e to the power minus 60. Is it not? Or this is equal to half Laplace transform of e to the power 2t minus the Laplace transform of e to the power minus 60. Just take that L inside because L follows the laws of, I should say the property of Laplace transform. I'll just write it in corner like this. If suppose you have constants c1 and c2 and some functions g and f and g of t, the variable t, the Laplace transform of c1 into f of t plus or minus c2 into g of t, it is always equal to c1 into the Laplace transform of f of t plus or minus c2 into the Laplace transform of g of t. This is the basic thing, that is your Laplace transform satisfies the linearity property. They are linear. Okay. By applying that property you can just take that half outside because it is constant, like how c1 and c2 are constants there. Okay. You can just refer this. See, if c1 and c2 are any two constants and f and g are any two functions of the same variable t, then the Laplace transform of this linear combination, it takes the value c1 into the Laplace transform of f of t plus or minus the Laplace c2 into the Laplace transform of g of t. By referring that, you can just write that constant aside and take this L inside like how we have taken there. Now this is equal to half Laplace transform of e to the power, yes, I'll just take this, okay. Now the Laplace transform of e to power 2t, it is same as the Laplace transform of e to power at. What is the Laplace transform of e to power at? It is 1 divided by s minus a. Here the value for a is 2, that is the quotient of t here. So it becomes what? 1 divided by s minus a means s minus 2 minus the Laplace transform of e to power minus 60 we need to write. It is as good as writing the Laplace transform of e to power minus 80, which I have written in the set of formulas I have given in the beginning of this video. Okay. So that is the Laplace transform of e to the power minus 80. We have written it as 1 divided by s plus a. Referring that, you will have 1 divided by s plus, value for a is minus 6 here. So it becomes s plus 6 here. Now take the LCM, half s plus 6 minus s minus 2 over s minus 2 into s plus 6, or it is equal to, simplify this further, plus s minus s will get cancelled, plus 6 plus 2, it becomes 8 divided by 2 times s minus 2 s plus 6. Again you can simplify it, it is 4 over s minus 2 into s plus 6. So this completes the solution for this problem. Okay. Now we'll continue with some more problems in my next session. Thank you.